If you're a healthcare professional, a hospital administrator, or even just curious about where this field is headed, you've probably heard the buzzwords: AI, machine learning, big data. But who are the actual people building these systems? What do they do? And how do their roles fit together to create the technology that's revolutionizing patient care? Today, we're breaking down the 5 core AI and data roles in healthcare. We're going to look at what each person does, the tools they use, and why their contribution is critical to the entire ecosystem. It's not just about titles, it's about understanding the unique skill sets that drive innovation in our industry. All right, so let's start at the beginning, the entry point. This is the data analyst. Think of this role as the frontline soldier of data. They are the ones who are closest to the raw information that fuels everything else up the chain. Their primary job is to take the massive, often messy streams of data generated in healthcare every single day. We're talking electronic health records, patient satisfaction surveys, insurance claims, even data from wearable devices, and make sense of it. They are the initial interpreters, tasked with collecting, cleaning, and organizing this information into a structured format that can actually be used for something meaningful. Without this foundational work, everything else just falls apart. It's not the most glamorous job, but it is absolutely essential. So what does their toolkit look like? Well, it's less about cutting-edge algorithms and more about robust, reliable tools for handling and presenting data. The data analyst lives and breathes in programs like Excel for quick data manipulation and analysis. But more importantly, they need to be proficient in SQL, or structured query language. This is the language they use to talk to databases, to pull out specific pieces of information from millions of records. It's a non-negotiable skill. They also need to be masters of data visualization tools like Tableau or Power BI. Their job isn't just to find insights, but to communicate them clearly to people who might not be data experts, like clinicians or hospital managers. Ultimately, the data analyst's output is often in the form of reports and dashboards. They might create a dashboard tracking hospital readmission rates or a report analyzing the effectiveness of a new patient care protocol. They answer the "what happened?" questions. Strong communication skills are therefore just as important as their technical abilities. They have to be able to tell a compelling story with the data, explaining trends and presenting their findings in a way that leads to actionable insights. They are the bridge between raw data and informed decision-making at the ground level. Next up, we have the data engineer. If the data analyst is the frontline soldier, the data engineer is the architect and quartermaster of the entire operation. They are the ones who build and maintain the infrastructure that everything else runs on. Their focus isn't on analyzing the data for insights, but on making sure that data is available, reliable, and secure for everyone who needs it, from the analyst to the scientist. They are the unsung heroes working in the background, designing the complex systems that store and transport vast amounts of sensitive healthcare information. They build the highways that the data travels on. The data engineer's world is all about pipelines and databases. They are responsible for creating what are called ETL processes, which stands for extract, transform, load. This means they build automated systems that extract data from various sources, like an EHR system, transform it into a clean and standardized format, and then load it into a central repository, like a data warehouse or a data lake. This is a massive undertaking in healthcare, where data is notoriously fragmented and inconsistent. They ensure that when a data scientist goes to build a model, the data they're using is accurate and trustworthy. This is the backbone of the entire system. In terms of skills, this role gets significantly more technical. A data engineer needs deep expertise in SQL, along with proficiency in programming languages like Python or Java. They work with big data technologies like Apache Spark and Hadoop to handle massive datasets that would crash a normal computer. And increasingly, they are experts in cloud platforms like Amazon Web Services, Google Cloud, or Microsoft Azure, where most modern healthcare data infrastructure is being built. Crucially, they have a laser focus on data security and governance, ensuring compliance with regulations like HIPAA. They build the vault, and they make sure it's impenetrable. Now we move to one of the most talked about roles, the data scientist. With the infrastructure built by the engineer and the initial data cleaned by the analyst, the data scientist steps in to find the hidden patterns and predict the future. They are the investigators or the detectives of the data world. Their primary goal is to answer complex questions and generate deep insights that can fundamentally improve patient outcomes or optimize hospital operations. They move beyond the what happened, that the analyst answers and start asking why did it happen? And more importantly, what is likely to happen next? This is where advanced analytics and machine learning really come into play. A data scientist in healthcare might build a predictive model to identify patients at high risk of developing a certain condition, like sepsis, allowing for earlier intervention. Or they might use statistical analysis to determine the most effective treatment pathway for a specific patient profile. They use their skills to sift through incredible amounts of clinical and operational data to find correlations and causal relationships that a human simply couldn't spot. Their work is at the core of what we call precision medicine and evidence-based practice. The toolkit for a data scientist is heavily focused on statistics and programming. They are fluent in languages like Python and R, and they use libraries like scikit-learn, TensorFlow, and PyTorch to build and train their machine learning models. A strong foundation in statistics is non-negotiable. They need to understand the theory behind the models to avoid drawing false conclusions. And just like the analyst, they need excellent data visualization and communication skills. It's one thing to build a complex model with 95% accuracy. It's another thing entirely to explain how it works and why it should be trusted to a skeptical room of clinicians. They translate complex math into clinical value. So, the data scientist has built a brilliant predictive model. It's working great on their laptop. Now what? That's where the ML/AI engineer comes in. This role is the critical link between the experimental world of data science and the real operational world of a hospital or clinic. Think of them as the specialized builders who take the blueprint from the data scientist and construct a robust, scalable, and reliable application that can be used by doctors and nurses every single day. Their job is to productionize machine learning models, which is a completely different challenge than just building them. The ML/AI engineer is focused on deployment, monitoring, and maintenance. They have to figure out how to integrate an AI model into the existing clinical workflow. For example, how do you get a sepsis prediction model to run in real time on data streaming from the EHR and then send an alert directly to the right nurse's workstation without disrupting their work? This involves a ton of software engineering best practices. They build the APIs, manage the cloud infrastructure for the model to run on, and ensure it can handle thousands of requests without crashing. They are obsessed with reliability, latency, and scalability. This role requires a unique hybrid skill set. They are strong software engineers first and foremost, with expertise in languages like Python and Java, but they also need a solid understanding of machine learning concepts. They are the masters of MLOps, or machine learning operations, which is like DevOps for AI. They use tools like Docker and Kubernetes to package and deploy models, and cloud platforms like AWS SageMaker or Google AI Platform to manage the entire lifecycle of the model in production. They make sure the AI isn't just a cool experiment, but a dependable clinical tool that works 24/7. Finally, we arrive at the most advanced and research-oriented role, the ML/AI scientist, sometimes called a research scientist. If the ML engineer is building with existing blueprints, the ML/AI scientist is the one inventing entirely new forms of architecture. These are the pioneers, the innovators who are working on the absolute cutting edge. Their job isn't necessarily to deploy models for today's problems, but to create the novel algorithms and techniques that will solve tomorrow's biggest challenges in healthcare. They are often found in the R&D departments of large tech companies, academic medical centers, or specialized AI startups. The ML/AI scientist is fundamentally a researcher. They might be developing a completely new type of neural network architecture for interpreting medical images with higher accuracy than ever before. Or they could be working on AI that can generate novel drug compounds or design personalized cancer treatments from genomic data. They are pushing the boundaries of the field itself. Their work involves formulating new hypotheses, designing and running complex experiments, and rigorously validating their results. Their goal is to create new knowledge and capabilities that don't currently exist. As you can imagine, the bar for this role is incredibly high. It typically requires a PhD in computer science, machine learning, or a related field. They possess a deep theoretical understanding of advanced machine learning and deep learning concepts. They are not just users of AI libraries, they are capable of building them from scratch. Their days are spent reading academic papers, writing their own for publication in top-tier journals and conferences, and coding up experimental algorithms. They need a rare combination of creativity, scientific rigor, and deep technical expertise to truly innovate and drive the future of healthcare AI. So there you have it, a full breakdown of the 5 core data and AI roles that are powering the future of medicine. From the data analyst laying the groundwork, to the data engineer building the infrastructure, the data scientist uncovering insights, the ML engineer productionizing the tools, and finally the ML AI scientist inventing what comes next.
Each role is distinct with its own set of skills and responsibilities, but they all work together in a tightly integrated ecosystem. Understanding the structure is key. Whether you're a clinician looking to collaborate with a tech team, an administrator trying to build one, or a professional looking to transition into one of these exciting careers, the world of healthcare tech is moving incredibly fast, and having the right people in the right seats is more critical than ever. If you're building out your organization's AI capabilities, or just want to understand the teams you'll be working with, feel free to save this video and come back to it as a reference. It's a lot to take in, but knowing the landscape is the first step. Thanks for watching. If you found this valuable, do me a favor and hit the follow button for more deep dives into the intersection of healthcare and technology. And if you know a colleague or a friend who would benefit from this breakdown, please share it with them. The more we all understand this space, the better we can collaborate to build a healthier future. Let me know in the comments which role you found most interesting or what topics you'd like to see covered next.